Okay, so just before we go over the lesson for today, I do just want to look at two of the problems from the practice from Friday. So just to go over a couple things that you guys need to make sure you're remembering when you're solving, and then a couple special circumstances that I believe I forgot to mention when we had our notes on Thursday, so that is my bad, but that's okay. We're just going to go over it now, and it'll all be good. So the first thing, this again is from the practice from Friday, the one that should have gotten handed back to you today. So first, number 7. So number 7 is tangent of x over 3 equals 1, and this is part of the section where it's on the interval from 0 to 2 pi. So the key thing here that we need to remember is that when there is stuff happening in the parentheses like this, so we have this division of 3 that's happening, you cannot just multiply both sides by 3 right now. That division of 3 is trapped in between the tangent, or inside the tangent, and you cannot multiply by 3. So remember what we do is we set whatever's on the inside, so in this case x minus 3, is going to get set equal to whatever angle has the tangent of positive 1. So in this case, that's going to be pi over 4. So I'll have an x over 3 equals pi over 4, and then an x over 3 equals our other angle with a positive 1 for tangent is 5 pi over 4. Now, at this point, now we can multiply by 3, but you cannot do it if it's trapped inside the trig function. You have to wait until you set it equal to an angle. So then we can multiply both sides by 3. Both sides. So we'll end up with x equals 3 pi over 4, and x equals 15 pi over 4. Now, the key thing, that this is the part I think that I forgot to mention on Thursday, so I apologize again. But the main thing is we need to double check our interval always. So in this case, we have an interval from 0 to 2 pi, so we cannot have any x values that are outside of that interval. 3 pi over 4 is within that interval, so that one's good. That would be one of our solutions. But 15 pi over 4 is greater than 2 pi. So that means this one will not be a solution because it is outside of our specified interval. So that is just one of our special cases that we need to remember, is that we need to eliminate any angles outside of the given interval. Okay, so that was number 7. The other one I want to go over from that practice from Friday is number 10. And so number 10 was 2 times cosine of 3x minus square root 2 equals 0, and that's on the interval still from 0 to 2 pi. So again, we do need to isolate our trig function, so this cosine of 3x. We need to get that by itself. We're not going to do anything with a 3 yet, but we can deal with that minus square root 2 and with this 2 being multiplied, because those two are outside of the trig function, so we can deal with those. So we can add square root 2 to both sides, and then we can divide both sides by 2. So we'll have cosine of 3x equals square root 2 over 2, and it's just the positive square root 2 over 2. So that means we do like what we did up here, where we take whatever is inside the trig function, we set it equal to the angles that have a cosine of positive square root 2 over 2. So that'll be, we'll have our 3x equals pi over 4, has a cosine of positive square root 2 over 2, and 7 pi over 4 has a cosine of positive square root 2 over 2. So we set both of those equal to what's inside the trig function. We set them both equal to 3x, and then we solve for x. Then we can deal with the 3. Divide both sides by 3, or dividing by 3 is the same as multiplying by 1/3. That's a little easier for you if you don't want to worry about double-decker fractions. So we should end up with x equals pi over 12, and x equals 7 pi over 12. And now this is one of the other scenarios that I forgot to mention. Again, I'm sorry, but we're going over it now, so it's okay. Again, we have this interval from 0 to 2 pi, and we need to make sure we get all of the solutions that are in that interval. And so in this case, we have pi over 12, 7 pi over 12. Both of those are still within the interval, but we haven't even reached pi yet, right? 7 pi over 12 is still less than pi. We got to get all the way to 2 pi. And so just like it's kind of the opposite situation where up here we had to eliminate any angles that were outside of the given angle, we also need to make sure that we get all possible solutions. So what we can do is we can keep adding our period to both of our solutions that we have here. Keep adding period to get additional solutions. And you'll just keep doing that. You'll keep getting your solutions until you reach 2 pi, because we can't go over 2 pi. Until you reach 2 pi or go over, that would be your stopping point. So in this situation, we have our first ones, right, are x equals pi over 12 and x equals 7 pi over 12. Those are both going to be solutions, so we can box them up. But then to get some additional solutions, we're going to need to just keep adding the period. Remember, the period is based on, or if there's a period change, it's when there's some numbers in this trig function with the x. So remember, our period is always 2 pi divided by b. b is that number that's being multiplied by x. So in this case, it's 3. So 2 pi over 3 is our period. So we're going to add 2 pi over 3 to both of our solutions here. Adding 2 pi over 3, if we get a common denominator, that'll be the same as adding 8 pi over 12. So pi over 12 plus 8 pi over 12 would give us x equals 9 pi over 12. That is still within that interval 0 to 2 pi, so that's a solution. We box it up. Do the same thing, 7 pi over 12. We add 8 pi over 12, and we get 15 pi over 12. That is still within our interval, right? 2 pi would be 24 pi over 12. Once we get there, that's where we're going to stop. But 15 pi over 12 is still in that interval, so that's an answer. We box it up. We add 2 pi over 3 again to both of these. Just keep on going. So we'll have 9 pi over 12 plus, again with a common denominator, it'd be 8 pi over 12. So we'll have x equal 17 pi over 12. And that is a solution. It's still within our interval 2 pi, 0 to 2 pi. Back over here, 15 pi over 12. We add 8 pi over 12. We have 23 pi over 12, so that's just barely under 2 pi, right? Again, 2 pi would be 24 pi over 12, so we have that one. So that one we're right under 2 pi, so we're probably done, but we can just check just to make sure. 17 pi over 12 plus 2 pi over 3 plus 8 pi over 12, that would give us 25 pi over 12, and that is over 2 pi, so that one would not be a solution, and so all 6 of these angles would be our solutions. So again, I know I didn't mention this before, so I didn't take any points off for this stuff on the practice from Thursday or from Friday. I just wanted to make you aware of these situations so that when we have these problems in the future, we know what to do. So all 6 would be our answers. Okay, so 2 different scenarios. Again, make sure if you have your 2 solutions and they're both in the interval, just add your period a couple times. Make sure that you have all of them. Keep adding until you get to 2 pi or more, so that's where you know to cut off. Or if you get your solutions and one of them is already bigger than 2 pi, or multiple of them are already bigger than 2 pi, or whatever the interval is, you just cross out the ones that do not fall within that interval. Okay, so that's the main 2 things I wanted to talk about today, those 2 different problems. Just some other things that I noticed as I was grading, just some like solving things, some algebra things. Just a reminder, when we have a trig function squared, so like let's say we had sine squared of x equals 3 over 4. Remember, this is the same as having the whole trig function squared, so sine of x squared. And this is the main thing. To undo the squared, you do a square root, but it has to be plus or minus. Whenever you are doing a square root, whenever you are adding a square root to a system, it has to be plus or minus. So we'll have plus or minus square root 3 over square root 4, which is 2. That's the main thing. You can't forget about the plus or minus. Whenever you are doing a square root, whenever you're adding it into this situation, there always has to be plus or minus. And then just another key thing when it comes to factoring, you can only factor, factoring can only happen when your equation equals 0. Factoring can only happen when equation equals 0. So for example, if we had 2 sine squared of x plus 3 sine of x equals -1, and we wanted to factor that, you cannot just take a sign out of these two terms because you cannot factor until our equation equals 0. So we'd have to add 1 to both sides first. And then we can factor. So factoring this one, we'll have 2 sine of x plus 1 and sine of x plus 1 equals 0. And then, right, because if we distribute, we'll have our 2 sine x squared that we have. 2 sine x plus sine x gives us our 3 sine x plus 1. So now you have your factors. Now you can set them both equal to 0 and solve for x from there. But you have to make sure you cannot factor until your equation equals 0. Okay, that's all the things I wanted to go over. So that's it for this video. There's the one more video you guys have to watch for just a short lesson for today, and then you'll have the rest of the time to work on your homework.